Let us talk about this problem. Consider a situation where you have a full day party. Party starts at 00 and goes till 23:59. You are also invited in the party and there are many other guests invited. You have list of all guests and you also know when are they going to come to the party and when are they going to leave from the party. For example, here there are two guests apart from you. The first guest is going to come at 9 o'clock and leave at 10 o'clock. The second guest is going to come at 9:40 and leave at 10:30. Please note that I have not used colon in the time to keep the question implementation simple so that we can use integers. Ideally it should have been 10::30, right? 10:30, but I have written only integer values. So 10:30 means 1030 means 10:30 time. So you have list of guests apart from you who are going to come to the party and their arrival and departure times are going to be from 0 to 23:59, right? Because party goes from morning 00 to night 23:59. Your target is to meet the maximum guests. You want to go to the party so that you can meet the maximum guests. And your target is to find out how many maximum guests you can meet. Let's understand with this example. Here we have two guests apart from you coming. One guest comes at 9 o'clock and leaves at 10 o'clock. The other guest comes at 9:40 and leaves at 10:30. So if you go at the time from 9:40 to 10 o'clock, you will be able to meet both of them, right? From 9:40 to 10 o'clock. Let's now see this question, this example. Here you have four guests coming from you, coming in the party. And these are their arrival and departure time. Guest 1 comes at 8 o'clock, leaves at 8:40, 7 o'clock, leaves at 8:20, comes 6 o'clock, leaves at 8:30, comes at 5 o'clock and leaves at 5:30. In this party, you can meet maximum 3 people. And what time you will go to the party so that you can meet 3 people? You will be going from 8 to 8:20, right? If you go from 8 to 8:20, the first 3 people will be there. This guy is there from 8 to 8:40, he is there from 7 to 8:20 and he is there from 6 to 8:30. So if you go from 8 to 8:20, you will be able to meet 3 people. And in this question, if you go from 9:40 to 10 o'clock, you will be able to meet both the people. In this question, you get the answer 3. Can you guess the time frame around which you should go to the party? You should go to the party from 11 to 11:20. If you go from 11 to 11:20, you will be able to meet this guy. He's there from 11 to 11:30. You will be able to meet this guy and you will be able to meet this guy. You will be able to meet 3 people if you go from 11 to 11:20. So you have 2 integer arrays given to you and you need to write a function that returns an integer value. And this integer value tells you how many guests you can meet at most. Now please pause this video and try to write down a function that takes 2 integer arrays and returns an integer value. Let us now talk about an efficient solution. We are going to use sorting here. Let's see how sorting can be useful to solve this problem in big O of n log n time. The basic idea behind the solution is we consider all the timelines starting from the first arrival to last departure, and at every time we see how many guests are there, right? And whatever is the maximum is our result, right? We'll go at that time and meet the maximum guests. Now if you see this example, there are 3 guests. One arrives at 6 o'clock, leaves at 8 o'clock. The second guest arrives 7 o'clock, leaves at 7:30, and the third guest arrives at 9 o'clock and leaves at 10 o'clock. So if I draw a timeline of all these guests, I'll get this timeline. At 6 o'clock, first guest arrives. We have count of guests as 1. 7 o'clock, second guest arrives. We have count of guests as 2. At 7:30, one guest leaves. So we have count of guests as 1. At 8 o'clock, one more guest leaves. So we have count of guests as 0. So A means arrival, D means departure here. 9 o'clock, one more guest arrives. So we have count of guests as 1. So between 8 and 9 there was no guest. At 10 o'clock, one guest leaves. So we have count as 0. Now if I go through all this timeline, I can notice that I have maximum guess here, right? So this is my maximum. So this is the basic idea to solve the problem, and we are going to use sorting to implement this idea. You would love to pause this video now and implement this idea yourself. Let us now take a look at the implementation of the approach. So we have a function max guess count that takes arrival, departure and size of the arrays as arguments. What this function does, it first sorts both arrival and departure arrays. If you are programming in Java, then you will use arrays.sort to sort the arrays. This is the syntax in C++. So we first sort both the arrays in increasing order. See, the point is we want all these events according to the timeline. Now we have two different events in two separate arrays. So we first sort both the arrays individually. So we get all the arrival events according to the timeline. We have all the arrival events and all the departure events according to the timeline. Now our task is to merge both the events and then keep on counting the guess at the current moment. Now this problem becomes very similar to the merge function of the merge sort. And if you take a look at this code, this is close to the merge function of the merge sort. This is what we do in the merge function. We compare array I with array 1i with the array 2j, and we do I++, otherwise we do j++. Something similar we are doing here. So what are we doing here? We have considered the first arrival here. We know that array 0 is ARR 0 is going to be smaller than departure 0 for sure, right? So we have considered beginning I from 1. We are going to begin from the second arrival. We have initialized j as 0, first departure. And since we have already gone to this event, right, we have already considered one arrival and our count of guests is 1. Our current guest is 1. Our result is also initialized as 1. It's going to be at least 1. So we have already considered the timeline when one guest has arrived. Now we are going to consider all the remaining events by merging both the arrays. So what we do, we say if current arrival is smaller than current departure, then this arrival event, the current arrival event is first. So take this event, increment the count of current guest because arrival has come before next departure, and do I++, go to the next arrival in the arrival array. And if current departure is smaller than current arrival, if the next event is a departure, then decrement the count, current count, and go to the next event in the departure. And whatever you do out of these two, you compare the current with the result. If result is less than the current, then you update the result. You basically are checking when you get the maximum result. So at this moment, you will have the maximum result as 2, right? And result will be updated here. It won't be updated after this. Let's now do a run of this code with this example. We have 3, 900, 600, 700, 1000, 800, and 730. We'll sort both the arrays, 6 o'clock, 7 o'clock, 9 o'clock, 7:30, 8, and 10. After sorting, we'll initialize these values, and now we'll run this loop. Now we'll compare, our I is currently here, right? And j is here. We have initialized I as 1 and j is 0. Now I'll compare these two. 7 is smaller, so array I is smaller. We have now 2 guests. At this point, we have 2 guests. And we update the result also as 2. And we increment the I because array I is smaller than departure j, so our I must have been incremented. So I becomes 2 now. Now we do the next iteration of the loop and we compare array I with array I, which is 2 now, with departure j, which is this now. So this time our array I is greater, right? So we fall into this if condition. So we do not change I, we change j. J moves to this point, right? J comes here. And we decrement the current count and we do not update the result because current is less than result. So our j has come to 1 and our I is here. Now we are going to compare these two, right? 800 and 900. 800 is again smaller. So we are going to make the count of guests as 0 and result is going to same as 2, right? We have current as 0, right? Less than result. Now we are going to go to the next iteration. In the next iteration, our array I is smaller than departure j. So we are going to increment the current, but current is not more than result, so we are not going to update the result. So you can notice that we have actually considered all the events in sorted order because we are doing something like merge of merge sort, and at every moment we have just counted the current guess and we have compared it with the maximum guessed so far, and we have updated the maximum. Let us now talk about time complexity of the solution. Time complexity of the solution is clearly n log n, because we have two arrays of of sizes n, and what we are going to do, we are going to sort the first array which takes n log n time, then we are going to sort the second array which also takes n log n time. And this loop is clearly big O of n plus n, right? That's similar to merge function, and merge function takes m plus n time if you merge two arrays of size m and n. So it's big O of n plus n, which is big O of n. So overall time complexity is big O of n log n plus big O of n log n plus big O of n, which is big O of n log n.